So I would like to briefly introduce 3 research projects carried out by our UNSW High Performance Architecture team. Will, Henry, Matt, Dale, Shuhan, Paul, Ricardo, Shamila, and our PhD students, Tony and Kenny. First project is Urban Heat Island Mitigation Decision Support Tool funded by Dell's CRC for low carbon living. Second is Cooling South Melbourne, funded by City of Port Phillip. The third one is current large research project funded by New South Wales Department of Planning and Environment, National Heat Vulnerability Observatory, Phase 1 Smart and Cool Places. I quickly go through this project with you. First one, Urban Heat Mitigation Decision Support Tool. This project, we look into 3 objectives. First is, can we provide government and the built environment industries with a decision support tool related to urban heat mitigation options to inform urban policy development, assessment, and planning practices? And the second, can we integrate scientific models with a range of mitigations techniques to perform urban heat island mitigation analysis across not only building scale, but also urban scale? And the third one is about urban heat island mitigation performance index, particularly requested by City of Sydney to support their decision making, in particular about the planning controls. So this decision support tool has applied in 3 case studies in Greater Sydney, Parramatta Civic Link, and Green Square. They are CBD redevelopment. Macassar High is new greenfield development. And I may not share details on this project, but just quickly have a screenshot to show the interface. So how this could support provide interactive scenario analysis to support decision making. Users can try the different development alternatives. So, for example, land surface materials, roofs, greenery, if they change different way, in particular in early planning stage, will that impact or help mitigate urban heat? To what extent it could reduce air temperature or surface temperature, improve thermal comfort? So from this case study, we can see the combination of mitigation options can achieve maximum reduction in local air temperature around 6 degrees. And similarly, the results we have achieved for Parramatta Civic Link redevelopment. Second project, the Cooling South Melbourne, that's in-depth case study. So same things. Okay. Thank you. It's in-depth case study because after the first project, we would like to see 10 urban development approaches to mitigate urban heat islands. And so, for example, and also to what extent, for example, urban form, parks, greenery, waterway, cool roofs, and so on, could have mitigation or reduce urban heat, improve outdoor thermal comfort. 2 areas we look into. One is public realm, and the second is built form. For example, the public realm include vegetation, roads, land surface, which Matt and Edward pointed very important. And the build form also important. So in particular, architects and designers, they want to know building height will impact on outdoor thermal comfort or not. And also facade materials, roof materials definitely make a big impact. So what we have done through this case study, we co-design, co-develop the mitigation options across the public realm and build form with city of Port Phillip. So this show you the context, the current condition in Melbourne, because city of Port Phillip is in Melbourne, and also urban development characteristics in the study area. Study area is called South Melbourne. So that is a key development area for increasing density within the city. And on the right side, you can see the very large exposed roofs of business retail industry areas in this study area. Very large block of buildings and dark roofs and wide streets without trees or with little trees. So then you can see the matter because the large building block, in particular the dark roofs, if we look at the heat map, that significantly impact on the surface temperature. And also, if we look at the wide street without the tree, with less tree, very high surface temperature. So we firstly identify the urban heat problems and then collect data. As Edward said, data sets important. It should be real-time data, dynamic, and should be updated over time. So we collect air temperature, humidity, wind speed, and direction, surface temperature, bone data, climate, and also the urban development characteristics. Then we further worked with city of Port Phillip to look into what cooling interventions the council, local government would like to consider. And both at the Great Melbourne area and also local study area, the precinct level. The modeling and the simulation we have done, including meso scale and also micro scale, as Edward introduced this morning. And then the cooling intervention analysis results help the local government, the city of Port Phillip, to inform their South Melbourne structure plan, and also their green influence structure strategy. They told us, oh, we have used your research outcomes. That's really significant and great. So this project has received the research excellence from the city of Port Phillip. Okay, so after many case studies we have done, we were thinking about, can those research outcomes benefit more cities across Australia? So similar, Edward talked about his index. We are developing National Heat Vulnerability Observatory Index as well, but different focus. Also, we are establishing the benchmark data sets. And all those data sets are updated over time, they are dynamic. So this project, now we are in phase 1, smart and cool places. We aim to provide an integrated and a consistent approach to measuring and reporting the heat vulnerability issues, because there are many studies, many studies have been done in the area. However, if we look into the data aspect, there is a lack of standardized approaches for data collection, reporting, and measurement of urban heat risks. So that's why we thought that that's very important and crucial, and in particular supported by New South Wales Department of Planning and also New South Wales Government Digital Restart Fund. This project includes 3 key components. The first is about developing heat vulnerability index benchmarking methods. So benchmark data sets are very important. We're developing the methodology. However, that's just starting. it's ongoing because with more cities are involved, we hope could further improve the benchmark data set. And the second is about urban heat mitigation scenario analysis. Is connected to the index benchmarks because the mitigation strategies could have reduced urban heat risk. Then to what extent it can reduce the urban heat vulnerability. So they are connected. I will introduce in a minute. And third part is data interoperability. So that's why I'm very interested in, I asked the question to Edward, how the communities are involved, how that are implemented, because our third component, data interoperability, is to collect the benchmark data index and cooling intervention scenario analysis with New South Wales government digital twin platform. So that's 3D platform, interactive platform. In future, hopefully could get the community involved. So for example, not like press button to know the risk, and also they can know their surrounding environment, the community, like the heat refugee centers where they can go, and so on. So through New South Wales 3D digital twin platform. So how this data can be collected, exchanged. So that's data interoperability, third component of this project. Okay, this shows how we construct the National Heat Vulnerability Observatory Index and benchmarking methodology developed by Will. And so you can see, as Edward and Matt indicated, that's very important to consider holistically. We have identified, so for example, from the influential factor perspective for urban heat vulnerability, that we consider local heat wave profile is more about climate, and then the community heat vulnerability profile, the population, the elderly people, young people, low-income people. So we need to have this data, and then built environment heat vulnerability profile. Also important to the urban, the built environment characteristics. So as Matt pointed, land surface, the surface material, the surface temperature that make a high impact, so how the built environment in local area sensitive to urban heat. So we consider that as well. So through the benchmark data sets, hope that can help us to identify which influential factors are significant in terms of the indicators that we have identified. We have defined the autothermal comfort, the heat-related mortality and morbidity. We received the health data from New South Wales Department of Health, and then electricity demand. So energy consumption during heat waves. The Ausgrid and the Department of Planning, they provide us very valuable data sets. We hopefully also could get metering data, so then we can monitor the energy consumption behavior during the heat waves. And then the mitigation and adaptation strategies. As I said, we integrate with mitigation and adaptation strategies to model the what-if scenarios of different mitigation options, see how that could reduce urban heat risk and to what extent it can improve heat vulnerability and also inform government policy. Okay, so then the data sets are important. So our index is built upon the comprehensive benchmark data sets. We have just started with a pilot in double region and mainland city. and then run the statistical analysis and regression model to find out some correlations. And some very interesting findings. Just give you a snapshot that's from where about heat-related mortality and morbidity across different case study precincts. So, for example, double that 32% increase average heat-related emergency department presentations, and also other compared to other case study precincts. And so that's intermediate the index, starting from the pilot of 2 cities. Once we have more cities involved, I hope that could be further developed. So these are 2 case study cities. One is a double regional council, western areas across New South Wales, as Matt said, that's the wind, the hot air coming through that really caused the very high temperature in double, and we visited there and over 40 degrees. And when we met the taxi driver, they said, "Oh, not hot today." We have more than many days over 40 degrees for the 2 or 3. Was surprised. And then Badland as well. So we picked up heat wave days during 2020 because we were like to link to health impact. We try to avoid the impact of COVID-19. So that's why we picked up that time period. So for double, most of the area have air temperature exceeding 40 degrees. And mainland, most of the area have air temperature exceeding 35 degrees. So these are the case study precincts. In double, particular double regional council, they wanted to look into different subdivision scenarios because that will impact not only private greenery area and also the surface, the land use surface. And for mainland, we picked up 3 case studies. The first one, addressing very high vulnerable populations. They are low income elderly people. And the second one, very interesting comparison between newly established suburb and old suburb with very high level of greenery. And the third case study, mixed land use. And you can see the heat map we have collected, which help us to identify overheat problems. I would like to point the right one of glassing that provide evidence to support the mass cool materials. That's so important because most the roofs, they are dark roofs. And then the surface temperature very much high. In that case study precincts compared to other case study precincts with a mix of dark roofs and white roofs. And this what we have modeled the different subdivision scenarios, mitigation options, and also example to show you the at the micro scale. So the first 2 images show the original air temperature distribution in the case study, and in the middle that showed air temperature reduction by mitigation options. On the right, that's the South Lake case study. Council really would like to change the subdivision scenarios. Then look at, okay, if we increase densities or reduce lot area into 300 square meter, or have townhouses, will that impact on autothermal comfort or the local air temperature? Or are there any mitigation options, cooling interventions could integrate with the different subdivision scenarios that could reduce overheat risk. So government want to understand the different scenarios and then support their planning controls. So the very interesting outcomes we have found at a meso scale. You can see the different line shows different mitigation options. Certainly, the combination of all mitigation options is highly effective. That makes significant reduction in terms of temperature can achieve up to 2-degree reduction. That's what we have looked into the maximum. And then followed by the greenery with water irrigation, and then the materials, then increase the greenery without irrigation. So city water is very interesting, knowing how much water is required. And similar findings we have got for mainland. So that shows you the patterns through almost 20 days or the 1 month. The air temperature reduction during the 2 cities during heat waves by different mitigation options. So this double and then we look into the test study precinct, so that's marker scale. MAT indicated or trees will generate heat if over 36 degrees. This provides evidence to support that. If we look at the time between 12 to 4 o'clock, the blue line that shows the air temperature reduction by increased greenery. So then, however, the gray line, that's air temperature reduction from applying cool materials to roads, footpaths, and private hard surfaces, then plus the other options were missing, which so then if you look at the time period between 12 to 4, the combination of not only greenery, but also cool materials and cool roofs and water misting and so on, that make air temperature reduction. So that tells us cannot just look into a single mitigation option. Okay, the third part is data interoperability. So we collect the benchmark data, sets, case study precincts, and what if scenario analysis of cooling potential with New South Wales digital twin platform. So that's open source to local governments, developers, and citizens, the communities. So this just shows you air temperature distribution across grassland in mainland cities. So that's one case study, and in double, and also the comparative analysis of air temperature reduction between the original base case and by the mitigation option. So you can see from the 3D visualization, you can see the cooling potential. Okay, back to the benchmark data sets. We developed the ontology, domain-based ontology framework. Then based on ontology framework, we developed the data structure for storing benchmark data sets. So that will enable the overheat vulnerability index benchmark data sets and measuring, reporting, connect with various or different government digital platform. Okay, the last slide. Now we are in phase 1. we would like to scale up to cover more cities in New South Wales and Australia. So that's phase 2. In phase 2, we would like to consider not only extend to include more cities, but also further develop the national benchmark data sets. And also we further develop interactive 3D visualization and decision support through New South Wales Digital Twin platform. The last one is about utilizing AI, artificial intelligence, machine learning for data-driven decision making for urban heat mitigation and adaptation. Thank you.